Okay, so today we're going to go through and we're going to talk about zero and negative exponents. And I want us to first think about this with a pattern. And so here's the pattern that I have. Let's say I start at 1, I go to 2, then I go to 3, then I go to 4. And the pattern of numbers that I get is 2, 4, 8, and 16. Well, first thing I got to do is, what is this pattern doing? Well, what this pattern is doing is it's taking the previous number and it is timesing by 2. So this next one would get me to 32. So at 5, that's what I would be looking at. So that's kind of the pattern. Sweet. Well, now I have all these unknowns on the other side of the pattern. And so going forward would be multiplying by 2, but how would I go backwards? How would I go backwards on this pattern? Well, to go backwards on this pattern, I could just divide by 2. And so when we keep dividing by 2, well, if we divided 2 by 2, oh, that'd give me 1. Well, how would I keep going? Oh, I could divide 1 by 2 and I could get a half. Oh, I could divide a half by 2 and I could get that is 1 over 4. And we can see kind of how this pattern is. Now what I didn't tell you before is this pattern is a pattern we use quite a lot. Like this really is 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, and 2 to the fifth. So this would be 2 to the 0 power, 2 to the negative first, and 2 to the negative second. Well, then that would mean that 2 to the 0 equals 1. And that would mean that 2 to the negative first equals 1/2, and 2 to the negative second equals 1/4, which is very surprising. The reason why it's surprising is 2 to the 0 doesn't equal 0. 2 to the 0 equals 1 because of this pattern. So exponents, things that exponents can't be. So let's talk about that for a second. Exponents they can't be 0. Because I can't raise anything to the thing and make it become 0. And exponents can't be negative if your base isn't negative. It just won't work out. So that's the big thing that kind of happens because of this, because we can see that negative numbers actually don't make it negative. It just further divides it, because that's the opposite of multiplying. And we can see that 0 doesn't equal 0. 0 for us equals 1. Let's do a couple of these things and see what they would become. So what's 5 to the 0 power? Well, 5 to the 0 power would be 1. What's 10 to the 0 power? Oh, well, that would be 1. What's negative 30 to the 0 power? Oh, well, that would be 1. Anything to the 0 power becomes 1. Well, what would x to the 0 power? It'd be 1. Anything to the 0 power, because of this this pattern, will become 1. Let's kind of look what's going to happen then with these other kind of exponents. 5 to the negative third. Oh, that means I'm going to divide the starting value by 5 3 times. So that would be 1 over 125. What would be 6 to the negative second? Well, that means I'm going to divide 1 twice, or 36. Okay, let's see this one more. Oh, so that would mean I would just divide that 4/3 times, and that would end up giving me 1 over, I think that's 64. Sweet, I got it right that time. Okay. So, easiest thing to kind of remember, negative numbers, negative exponents repeatedly divide, so they will make the numbers smaller. Zeros always become 1 because of this pattern that happens right here. And that pattern would work for any exponent no matter which one that you pick. Let's do complicated things now with variables. So let's say I was given this variable right here. Again, first thing that I want you to do for any of these problems, separate them. Next thing you want to do, we don't really want to have negative exponents ever. So how you deal with negative exponents is, well, this is actually saying I'm dividing x twice. Because that's the opposite of repeated multiplication, is division. So that would look something like this. Let's try another one. Okay. In this example, again, I want to think about these things being separate, so they're not attached. And since they're not attached, we are just going to see what 4 to the negative third. Well, we've done that before, which that's 64 on the bottom. X squared, well, I can't really simplify that anymore. And y to the negative third, well, that is going to be dividing y 3 times, and then I will get that. Last problem I kind of need to do. Say we're given this. Now this one's a little bit tricky, because if we kind of read this through, well, 5 is going to stay on the top because it's multiplication. X is going to stay on the top because it's multiplication and there's nothing to do. I have this negative y to the third on the bottom. And this one's a little bit tricky because we're already dividing it, but we're saying divide this by that 3 times again. So we really have a divide situation. And whenever you have a divide, it kind of flips around the whole operation because you have an opposite situation. So this will flip this to the top. Let's do one more of these. Well, in this one, again, I have 3 squared, which I can do as 9. This says divide, so since it's divide, I'm going to throw it to the bottom. And this time, x doesn't have any kind of exponent to move it anywhere, so we're just going to write x. I went through a lot of types of examples to kind of go through so you could see kind of the patterns for how this works. And there's a lot faster methods for everything that we've done. The best thing for you to do, though, is just this table is a really good table to kind of understand how it's produced. Like when I repeated multiplication is positive exponents, repeated division is negative exponents, 0 always equals 1. Okay? Try the different homework problems that we have for today.